So just to kind of remind you, with polar coordinates, we are talking about basically with the angle, where our point is going to fall. And of course, what we call as the directed distance. So basically how far away from the origin you are. Now in polar coordinates, your origin, which is O, is what we call as a pole or, origin as we're familiar with it. You've got your initial ray, which is what we call as the polar axis. So, that's the one that goes basically from the origin to where our angle 0 basically falls on, our unit circle. So kind of imagine that. That's what we're calling as the polar axis. And then we have our R value. So as part of the polar coordinates, your, two numbers are going to be R, which is the distance basically from your origin to wherever the point is going to fall. So you will see how in this illustration, we're defining R as this distance over here from the origin to the point. And the angle theta is basically telling you, when you start from that initial ray or the polar axis where your angle is going to fall. So that's kind of how. Oh, I forgot to open my web assign. So let's take a look at, how we can find these angles. But one thing I wanted to show you, we're so used to when we work with our X and Y coordinate plane. Why is it taking me in the student section? Yeah, it seems to be taking me in the student mode, but I guess we'll just let it be. As long as I can get to the textbook. All right, while that guy's coming up. What I wanted to talk to you about is, with the X and Y coordinate system, the rectangular plane, we're so used to, one ordered pair only giving you one exact point, right? There's usually you're not going to see, for the same ordered pair, we can come up with two different points. But that's actually not the case when you are working with polar coordinates. So what happens is with polar coordinates, for the same coordinate pair that you have, the R and theta, you can actually do theta plus 2 pi, and you will still land up at the same point. Because think about it. If you're adding 2 pi, that means you're basically forming one circle around it, right? So you're basically going a whole circle around it. So you can do, whatever the angle is plus 2 pi, and you land up at the same angle anyway. So those will give you the same point. Or we can do R theta and negative R theta plus pi. And that will also land you up at the same point. So look at how we have, for the same ordered pair, R and theta, you can do R theta plus 2 pi. For that same point, R and theta, we can do negative R theta plus pi, and it's going to land up at the same point over here. So what they have done is they are giving you kind of this general representation for, so this one over here is just a general version of this example here. And then the second one, this guy, is going to be the general example of this one. So you can see both of these are going to give us the exact same point, but that angle is what is going to change. So this is what we will be using in our first example over here, because they're going to ask us to plot the point and also find multiple representations for that same point. So let's take a look at our first example over here. What did I have? Number 8. So for number 8, all right, so they are giving us plot the point given in polar coordinates and then find 3 additional polar representations, leaving our angle from -2 pi to +2 pi. So if you look at, polar coordinate, and I'm not sure if I have this in your D2L or not, but you can Google it and find it. And this is what your polar coordinate ends up looking like. So you will see, as far as those angles go, your angles are still going to be those same angles that we have over here in our unit circle. So same angles over here, but then, when we talk about that R value, which is the directed distance from our origin, so that's where these circles, these concentric circles are coming from. So if you have a distance of, 1, then we will be in that first circle. If you have a distance of 2, then, we would be going out 2 units from the circle. So that's actually what these concentric circles come out to be. So our ordered pair over here is +1 and -3 pi over 4. So +1, I guess we'll do that over here. So +1, -3 pi over 4. And, so if you're doing +1, then that's going to be the first circle that you will have from your origin. So if we kind of did this as our vertical, horizontal, just to kind of get a grid going. Now, where do you think your -3 pi over 4 angle is going to be in, if this is our polar coordinate? Because you can see where the +3 pi over 4 is. So where will our -3 pi over 4 angle fall? Because remember, when you're going in counterclockwise, that's positive angles. When you go in clockwise, that's negative angle. So Billy, you are saying 7 pi over 4. All righty. So think about this. When we are going counterclockwise, this is how you come up with, okay, not a problem, Billy. You are coming up to 3 pi over 4. So you have to travel, basically the same distance to get to -3 pi over 4. So again, you are starting out with that initial ray, or, the polar axis as we're calling it, and go the same distance. So yeah, Shu, you had it in there. You are going to be at 5 pi over 4. So yeah, very nice. So at 5 pi over 4, and then you are going a distance of 1 unit. So you are going to land up at actually this point over here. So basically, if we're doing this by hand, and, obviously these lines are not going to be very accurate. Let's see, there should actually be 3 lines in here. So we'll break it down a little bit. And so this is going to be your -3 pi over 4. And then, if this is our distance 1, then this is where you are looking at that ordered pair of 1 comma -3 pi over 4. And again, I think in WebAssign, there's 2 types of questions, one where you plot the point and one where you choose out of the graphs. So that's going to be the graphing part. Now they're also asking us to find 3 additional polar representation. So we need to find 3 additional points. So this is where, these definitions are coming into play. So think about this. If we did, let's say using that first one, theta plus or minus 2n pi, if you had to use something like that where n is an integer, what do you think one of our possible points can be using the first breakdown? And then what was our other one? Theta plus or minus 2n plus 1 pi. Okay, let's see, Abdul Aziz, you've got -1 pi plus 4. So what did you use your n value in that case, Abdul Aziz? 0. So basically you did theta plus pi is basically where you ended up with. And use your unit circle again to help you out. Because if you are just taking the original angle of negative 3 pi over 4 and you're adding pi to it, that basically means you are moving your graph by 180 degrees. So of course, if you're moving it by 180 degrees, you're going to be on the other side. So that will definitely give you pi plus 4. So that looks good. And this is where you used -r as your representation. It's not letting me move my screen over here. Okay, it is not letting me move my screen. So -1 and pi over 4 looks good. And then Abdulaziz, I think you had another point in there. 1 and 5 pi over 4. Yeah, and that is actually coming from the 2n pi. So what was your n value in that case, Abdulaziz? Yeah, keeping it simple, right? So you're just doing the n as 1. So you're basically doing 2 pi added on to your -3 pi over 4. So for this guy, all you are doing is, if you take, on the negative side, this is 3 pi over 4. And if you add a whole complete circle to it, so we start from here, and if you want to go in counterclockwise direction so that you can get a positive angle. So going in that counterclockwise direction, it actually brings you to that positive side of the angle, which will give you 5 pi over 4. So that will be 1 comma 5 pi over 4. And we need one more angle. So those are 2 that we came up with. We need one more angle. So what can you modify in that case? And this guy had n equals 1. Because remember, n can be any integer. So what else can we do? Anybody have an answer? What if you changed n to, 2 or something like that? Okay, so Shu, tell me, what did you use for your n value? Because you guessed it. Okay. All right, so one thing, since you're going with -1 as your R value, that actually tells me that you are using this version of your equivalent, point. So in this case, since we've already used n equals 0, which is what Abdul Aziz had done, think about what happens if we use n equals 1 over here. So if you did -1 and then our theta was negative 3 pi over 4, and then we are, I guess, let's say we are adding, and you do 2n plus 1, where your n is equal to 1. So, well, 2 times 1 is going to be 1. 2 times 1 is going to be 2. 2 plus 1 is going to be 3 pi. So what will happen if we add negative 3 pi over 4 with positive 3 pi? What will that come out to be? Because you will see, Shu, there's one tiny mistake in your ordered pair. From where, I guess, like you said, you guessed it and then actually work it out. Because what's going to happen is you will need to find that common denominator when you're adding these numbers up. So since you have 4 as your denominator, of course, we end up multiplying this fraction by 4. So we end up getting negative 3 pi. 4 times 3 is going to be 12. So you do 12 pi over here and then over 4. So you will see 12 minus 3 is actually going to be 9 pi over 4. Shu, do you see that? Yeah. So you just have to be a little bit careful. Now, if you use, if we're using a plus sign over here, you can change that to a minus sign and you will get a different measurement in there. So, just use these two versions of finding those equivalent points and just keep changing your n. Now, n is an integer, which means you can do n as a positive number or n as a negative number. Yeah, very nice, Abdul Aziz. So our third point here will then come out to be -1 and 9 pi over 4. But guys, remember, these are literally 3 options out of infinite number of options over here. Now, let me ask you something. Is 9 pi over 4 going to be within our range of -2 pi and +2 pi? Or is it outside of it? It's outside, right? Because 8 pi divided by 4 is going to give you 2 pi, which means 9 pi over 4 actually falls outside the range of this that we have over here. So how can we fix that? So that means we cannot use 9 pi over 4. Because your angle theta has to stay between 2 pi and -2 pi. So what do you think we should change here? How about if instead of using n equals +1, maybe try using n equals -1 and see what happens? I think I wish I knew how we could move this guy. There we go. So if we did -1, 2 times -1 will be -2. -2 plus 1 will be -1. So what if we added a negative pi to this? What would we then end up getting over here? find your common denominator. So, multiply this fraction by 4, which will end up giving us -3 minus 4 would be -7 pi over 4, and -7 pi over 4 is going to be less than -2 pi. So this guy is going to be in the range of our angle measurement. If they did not give us that restriction, this point would have been fine, but since they do have that restriction of where our angle can be, you have to be careful about which numbers you put in here. So this is when n equals -1. If they did not give us that restriction, then this would have worked, but because of that restriction, you have to change your answer. So just some things to kind of keep in mind as you are looking through these different examples. So this was one example over here. And then I also had, just to give you a different version, number 12 that I wanted us to look at. Same kind of thing, obviously, but they're starting out by giving us -3 as the R value. And then, of course, 11 pi over 6 as our angle. So let's take a look at this guy. -3, 11 pi over 6. Oh, 11 pi over 6. So since this is -3, that actually means we will need 3 concentric circles to make our, this is just going to be very rough just to give us those 3 circles. Okay, something like this. So 11 pi over 6, where do you think that angle falls on our unit circle? And how will we do the -3 part? So this is probably where I would actually start by finding out our equivalent. Yeah, Abdul Aziz. So let's start by actually finding the 3 additional points first, and then we'll talk about graphing these. So again, remember that's R theta plus or minus 2n pi. And then for the other one, you have -R theta plus or minus 2n plus 1. So I would actually go ahead and start with the +3 first, so see what happens. So if we did this as +3, then you would be using one of the first ones. So 11 pi over 6, what would you add or subtract to try and find its equivalent angle over here? Because, again, what happens if you use n as 0? What would you have? So let's just do a plus sign by using n equals 0. And if we did n equals 0, you're actually just leaving the original angle as it is, right? Because 0 times 2 times pi will become 0. So that doesn't give you a whole lot. So, change it to +1 or -1 and say, let's say we change it to +1 for now. So that means you are adding, 2 times 1 is 2. You are adding 2 pi to it, but, obviously it still just brings you back to the original angle where you are at. So what else can we change it to? How can we find an equivalent angle? What if you did the other version, -R and theta plus or minus 2n plus 1 pi? because maybe that one will work better. So for which one are you using n equals 0? Abdulaziz, the second one with the negative r or the first one? For the second one, okay. So what happens if you try n equals 0 over here? So this guy will give us, let's try that. So if we left this at -3, we've got theta as 11 pi over 6. If you're using n equals 0, then the 2n becomes 0, and you've just left behind with plus 1. So that becomes plus pi, or you can do -3, 11 pi over 6 minus pi. Any of those will work. So what this will actually end up doing is giving you the ordered pair. You know what? Let's finish this before we move to our graph. There we go. All right, so this guy will come out to be -3. And as you will see, when you do the plus pi, it actually gives you a larger number, because now that will become, multiply this by 6. So 6 plus 11 will end up giving you 17 pi over 6, which goes beyond our angle limits. So this guy actually doesn't work out for us, because remember, your theta has to stay between, this laptop is still not 100% what I want it to be. So remember, again, your theta has to stay between -2 pi and +2 pi. So simply because of that restriction, this angle doesn't work out to be, but I think the other one will be fine. So this can give you same thing, multiply by 6, but now you are doing 11 minus 6, and of course 11 minus 6 gives you 5 pi over 6. And you will see when you are adding or subtracting that pi, it basically makes you move the graph 180 degrees. So at 5 pi over 6, you actually end up over here. So that's going to be one of your equivalent angles, -3, 5 pi over 6. What other two interpretations can we have for the same ordered pair? Staying within those angles of -2 pi and +2 pi. So since n equals 1 did not work for us, can we do n equals -1 on that first part? Yeah, what will that give us? If you change this to -1, that will basically end up making this guy +3, 11 pi over 6. -1 will basically make you add or subtract depending on what direction you're going in, but you can subtract 2 pi from that, and what will that new ordered pair end up looking like? So what is 11 pi over 6 minus 2 pi going to give us? Billy, yeah, very nice, because you will basically end up with 11 pi over 6 minus 6 times 2 is 12. So this guy becomes 12 pi over 6, which will basically give us negative pi over 6. And negative pi over 6 is going to be within our angle over here. So very nice. And we need one more, guys. Shu, very nice. Yeah, very good. So one more point. What can we have? So think about it. What can your n value be? What can you add or subtract? To get an equivalent ordered pair. So I'm actually going to go back if this guy will let me. -2 for the second one, Katie, okay? All right, so think about this. We are at basically these two angles, 11 pi over 6 and 5 pi over 6. Now imagine if instead of going in the counterclockwise direction, we go in the clockwise direction. So of course, clockwise directions, this is where this guy becomes negative pi over 6. What do you think this angle will become when you go in the clockwise direction? Okay, no problem, Lowell. Okay, so till you guys are thinking about that, it's not that hard of a question. Let's see what happens with Katie's example of using -2 on our second one. So what happens if we use n equals -2 over here? So that will end up giving us, let's see. Since we're keeping that negative, this guy will be 11 pi over 6. And then let's see, with -2, that'll be -4 plus 1, which will be -3 pi. So -3 pi will land us where, Katie? There we go. So same thing, multiplying this guy over here by 6. And what angle are we looking at? And is it going to be within our range of -2 pi and positive 2 pi? So let's see, 6 3s are 18. So this will be 11 pi minus 18 pi over 6. So that will come out to be, yeah, -7 pi over 6. Shu, yeah, very nice. Katie, very good. Alrighty. So -3 and -7 pi over 6. And that's exactly the angle I was talking about, because again, if you look at this from the from the clockwise direction, this angle here, it actually becomes the negative of 7 pi over 6. So basically it becomes the negative of this angle over here, and you will see that's exactly where we landed up at. So that guy is the first line. So when you graph this, this is going to be our 5 pi over 6. And since this is -3, you are going to be coming out to the third ring. And this is where that angle is going to fall in terms of your, plotting this point. So just, different way of looking at how these polar coordinates work, how you can find those equivalent angles, because literally it's just about, moving those angles in basically 360 or 180 direction, and you can still find the same exact point, just, with different angle measurements, kind of what they're talking about here in your handout. All right, so that was just in terms of, finding those multiple different representations or plotting them. Now, of course, we are interested in conversions, because what if we wanted to convert this from rectangular coordinates to polar coordinates or vice versa? So that's actually where this relationship comes into play. And again, you can see that in the video lecture, but I wanted to show you what those formulas end up looking like. So you can see this little illustration we have over here. So you've got your origin, at the origin of a rectangular coordinate, your polar axis ends up becoming your positive x-axis. And then you can kind of see how we are able to find, the same point, but rectangular or polar coordinates. So now if you are going from polar to rectangular, this is going to be your formula. So the x value is defined as r times cosine theta. Remember, r is that direction, directed distance over here. And, of course, theta will be where the angle is. Using that and the cosine and sine functions, we can find the x and y values. But if you are going from rectangular to polar coordinates, then we have to use this idea of tangent of theta is y over x, and r squared is defined as x squared plus y squared. So let's take a look at these conversions next and how we can simplify these. So we are looking at number 28 and 50. All right, number 28 over here. So this one is actually going from polar, and we want to convert them to rectangular. So going from polar to rectangular. And of course, you can see they're giving you negative 4 pi over 3 as your angle measurement. So of course, we know we are looking at polar coordinates here. So we are going from polar to rectangular. Let's go ahead and write our points down. Let's see, -2, -4 pi over 3. So when you are going from polar to rectangular, we define x as r times cosine of theta. We define y as r times sine of theta. And if you actually go back, guys, and look at, when we had defined these in chapter 1, when we were doing the different formulas and definitions, you will see we actually had similar definitions in chapter 1. So they're not really bringing anything new in here, as far as these conversions go. So just using those definitions, you will see over here with our polar coordinates, this is our r value, this is our theta. So literally just plugging this in, so -2 times cosine of -4 pi over 3. And for y value, same thing, -2 times sine of 4 pi over 3. So let's find that negative 4 pi over 3 on our unit circle. So which angle is negative 4 pi over 3? You see the positive one, but what's the negative one? What's the equivalent to your negative 4 pi over 3 on the unit circle? So in the counterclockwise direction, this is how we come up to 4 pi over 3. So where will you go to get your negative 4 pi over 3? Very nice, Abdul Aziz. So if you travel the same distance going in the clockwise direction, that would be, the full 180 degrees like we did, and then coming out to the farthest third one, which will be this guy over here. And that's going to be a 2 pi over 3, which is same as negative 4 pi over 3. So this is the ordered pair you are looking at. Remember, the first one is cosine, second one is sine. So you're going to use that in your definition. So cosine is negative 1/2. So this will now become negative 2 times negative 1/2, which is going to be the value for our cosine function. Same thing we'll do for the sine function. So this will again be negative 2, which is our R value. And then sine is square root of 3 over 2. So this guy becomes square root of 3 over 2. So what is your final answer for the X and the Y value over here, guys? Let me see when you simplify this, what you come up with. And as always, if it helps, you can write this as over 1 to make it into a fraction. So what do you get for the X and what do you get for the Y? Yeah, very nice, Abdul Aziz. So Billy, very good. So in this case, you will see on that first one, Katie, yeah, the 2 will cancel out. 2 negatives become positive, and this will end up giving you positive 1. Very nice, Shu. Same thing's going to happen here. The 2's cancel out, but since you only have 1 negative sign, that negative sign stays, and you end up with 1 and negative square root of 3. So very nice. In rectangular coordinates, this guy will become positive 1, negative square root of 3 as our X and Y values. Of course, on the graph, it will still be the same point. It's just going to be depending on which coordinate system you're looking at, the numbers will look different, but on the graph, it's still going to be the exact same point. All right, guys, this was number 28. Let's look at number 50 next. I think this is where we should be going in the other direction. Okay, yeah, so this is given to us in rectangular coordinates. We're converting them to polar coordinates. And again, just depending on the angle, you can have many different answers, and they're not giving us a restriction on what our theta should be. But, obviously we'll just keep it simple as we simplify this. So let's go ahead and do our conversion here. So, oh, wow, this is interesting. We've got negative 1 and positive square root of 3. So remember, this is going to be the X and the Y value. So when we are going from rectangular to polar, this is where we define tangent theta as Y over X And then r square is defined as x squared plus y squared. And since r is, that directed distance, you can also use this alternative format where we take a square root on both sides, but we only keep the positive because, like I said, it's a distance and distance cannot be negative. So you can kind of think of this also as being r equals the square root of x squared plus y squared. So these are, again, the same formulas that I showed you over here. So remember, for the polar coordinates, we need to find the value of r and theta. And that's what these two formulas will help us do. So let's see, what this ordered pair comes out to be. So we'll start with the tangent function first. So tangent of theta is going to be y, which was square root of 3. X was -1, so that comes out to be negative square root of 3. So this one, you can actually use the unit circle to see for which angles is our theta going to give us a tangent value of negative square root of 3. So what do you think our theta should be? For which angles is your tangent function going to be negative square root of 3? Because, if tangent is negative, then either sine or cosine has to be negative. Both of them cannot be negative and both of them cannot be positive. So which angle do you think we will get negative square root of 3 for the tangent function? 2 pi over 3, 5 pi over 3. Okay. Let's start with 2 pi over 3. So 2 pi over 3, obviously you do sine divided by cosine to find the tangent function. So if we did square root of 3 divided by square root of 3 over 2 divided by -1/2, you can invert that and you will see the 2's cancel out, leaving you with negative square root of 3. So yeah, very nice. And then you guys also had 5 pi over 3, which is going to be this guy over here. And, same thing, when you divide sine by cosine, you get the same answer. So, we can stay with the smaller of the two angles and we can do 5 pi, 2 pi over 3. So that gives us our theta over here. So that is taken care of. Now let's do the r value. So that can be r equals, square root of x squared plus y squared. So x was -1 squared. Y is square root of 3, so that would be square root of 3 squared. So, of course, since you're doing -1 squared, the two negatives will become positive. And then what do you think will happen with the square root of 3 when we square it? Yeah, there you go, because your square and square root will cancel each other out, and very nice. You end up getting just 3 over there. So 1 plus 3 is 4, and of course, square root of 4 is 2. So that gives you your theta from the tangent function, and then this formula ends up giving you your r value. So now we are looking at, 2 for this guy and 2 pi over 3 for this guy over here. Now remember, with those equivalencies, you can definitely have other angles for 2 pi over 3, but we just went with the smallest angle over here. So that gives you your polar coordinates for 2 and 2 pi over 3. So again, guys, very, very simple as long as you follow those conversion options over here. So this was just going back and forth between the polar and the rectangular coordinates. Now let's take a look at our next type. And I think this one is where we do the equations. Okay, so we're looking at 66. So this one is asking us to convert the rectangular equation to polar equation. Okay, so again, rectangular to polar. Let's go ahead and write this guy down. 3x plus 5y minus 2 equals 0. And you will actually see, you know, obviously there's going to be a lot of similarities between those conversions also. So, you know, if you just look at these examples, you will see we're still using the same formulas. So we are still defining, you know, x as r cosine theta, sine as r sine theta, and then, you know, of course, in the other direction, you are doing tangent of theta, y over x, or r square equals x square plus y square. So still using those same conversions here. So we will start with replacing our x with r times, sorry, this is x is cosine theta, plus 5y is r times sine theta. And do I want to move my 2 to the other side, or do I want to leave it? You know what, let's move it. If we need to bring it back, we will, but let's go ahead and move him for now. Okay, so just starting by replacing our x and y variables. Now, you know, multiply your number on the outside. So this will basically just change to 3r cosine theta plus 5r sine theta equals 2. And then I think the only thing we need to do is, since both our sine and cosine functions have that r in common, we can bring the r outside as our common factor. So that will leave us with 3 times cosine theta, and this guy will become 5 times sine theta, and this will equal 2. And then the very last thing we have to do is isolate the r. So all you need to do for that is just divide both sides by what we have inside the parentheses. And this will help us get r by itself. So 2 divided by 3 times cosine theta plus 5 times sine theta. And that's all you are doing, of converting this from rectangular to the polar form. And like I said, you can see some of these examples they have over here. This one was, I think, actually going from polar to rectangular, and we'll look at an example like that, but it looks like I didn't include an example with rectangular to polar. How did that happen? Okay, not sure how I left that out, but that's okay. You guys at least got to see an example here. So this is what you are looking for. This is going to be our final answer of, you know, our polar form of the rectangular equation. Okay, so this was one example, and I had one more here, so that's 72. And let's look at that now. so just a different version, but just to kind of show you, what happens when your equation is given in a slightly different format, because you will see this guy over here has x squared plus y squared equals 9a squared. And so what happens in this case here, is remember your equation has to be in the form of r equals something like we did in the previous one. So if you just look at the equations that we have defined, we are defining r squared as x squared plus y squared. So literally you can take this side where you have x squared plus y squared and replace it with r squared, and you end up with r squared equals 9a squared. You want to get r by itself. So to get r by itself, of course, we end up taking square roots on both sides. With square roots, we normally get positive and negative, but again, since r is that distance, we are going to discard our negative root over here. And so that will end up giving us the r square and square root cancel out. If we take square root of 9, we get 3. And same thing's going to happen with that a square. The square and the square root are going to cancel out, giving us r equals 3a. And that's it. That's going to be your answer for this guy. So that's the reason why I wanted to show you this example. Because, otherwise we would think about, let's substitute x with r cosine theta. Let's substitute y with r sine theta. But you don't have to do that in these types of equations where you already have x squared plus y squared. Just replace it directly with r squared, and then you can go ahead and try to isolate that r by itself. So just a different version of converting this from rectangular to your polar form. Okay, and then the last type of example, let's take a look at that guy. 102, 106. Okay, so this one is describe the graph of the polar equation, and then you're basically finding the corresponding rectangular equation. So you will see how in 102, they're just giving us r equals 8. And we have to convert this to rectangular coordinate. And 106 is something similar. They're giving you r equals 2 times cosecant theta. And we have to write this, in our rectangular form. So let's see how we can go about doing that. So 102 is r equals 8. So since we did the rectangular to polar, can you kind of tell me what's your first instinct of trying to convert this into a rectangular form? Rectangular equation, where would you start? What do you think we need to do here first? Which conversion would you use?
Would you square both sides first?
Very nice. Yeah. So kind of working backwards what we just did with the previous example. So very good. Start by taking square on both sides. And again, we're doing this so that we can bring in this idea of r squared equals x squared plus y squared. So, again, replace this guy here with x squared plus y squared. And then, of course, you end up getting 64. And that's it. 8 squared is 64, and this is your polar coordinate. So literally you just want to bring in those x and y variables and get rid of the r or theta or whatever else you may have in there. Very nice, Katie. And then of course, if you recognize this equation, this is the equation of a circle. So this would be our x and y coordinates plane. And then, 64 means you have a radius of 8. So that would be, if we went out, and I'm just doing this in 2 so I can save some space, but if you went out 8 units, in all directions, no, I'm a little off, but you kind of get the idea of what that guy would end up looking like. So that's what your graph would be is, because they're not giving us an angle. So angle can be anything, but your directed distance is going to be 8 units out. So that's kind of what we're looking at over here. We can adjust those markers to match our graph so you get an idea of what we're looking at. Okay, so let's see what happens with that 106, which was r equals, I think, 2 times cosecant theta. Yeah, 2 times cosecant theta. So what do we know about cosecant theta that we can use here? How do we normally define cosecant theta? Very nice, Katie. Yeah. So you've got cosecant theta equals 1 over sine theta. So just imagine what would happen if we try to clean this up a little bit. We've got r on this side. I can rewrite this as 2 times 1 over sine theta. So if I wanted to get rid of that guy, I can multiply both sides by sine of theta. This would cancel out here. And 2 times 1, we would have 2. And what does r times sine theta remind us of from this section? R times sine theta is defined for which? Yeah, Katie, very nice. R times sine theta is what we define for the y value. So this guy will become y equals 2. And so again, if you try to graph that, so again, in your x and y coordinate plane, y equals 2, of course, is a horizontal line, that passes through the point y equals 2. So it actually comes out to be a straight line in your rectangular coordinate plane, like this guy came out to be a circle. So, each equation is going to be different. Each conversion is going to be different depending on, what your polar form is given to you and how you can manipulate it to convert it into your rectangular format. So as you can see, there are a bunch of different examples. You've got some of these examples in your homework assignment also. So look through those, get yourself familiar with it. But this is where we are stopping as far as the final exam goes, so 6.7. Now, as I had said, when we get into 6.8, you will see this is actually where we get into the different types of, different shapes of graphs that we can create from our polar coordinates. So you will see, I don't know if we're defining them over here or not. Just hoping to show you the different shapes. So yeah, you can, come up with different shapes based on, what your r and theta values are going to be and what your polar equation ends up looking like. So just look at all the different formats or forms your graphs can take. And I think there is a little table that kind of shows you what each of these different graphs end up looking like. Yeah, so right over here, you can see how we're talking about the limacons, with the heart-shaped ones, with a little bit of a dimple or just a little convex. On there, we've got these rose curves, depending on how many petals your graph will end up with. You've got your circles and lemniscates. So a lot of different graphs that are in here. But, obviously we don't have a whole lot of time to go into details with this. So that's why we're, leaving this section out. As long as you understand the basic format of what polar coordinates are and how they transfer into a rectangular coordinate plane, you guys are still looking really good in terms of understanding, what your polar coordinates are. So I didn't realize it would actually take us quite this long, but this section really, I think we needed to spend the time that we did on this just to make sure you guys are comfortable with the conversions and everything. I just wanted to say one thing about the final exam is, obviously your final exam is going to be comprehensive. So it goes from all the way from, where we started out in chapter 1 to 6.7 for us this class. So, look through all those different definitions that you have. If you can really get a good foundation with that chapter 1, everything you did after that was just flowing from what you did in chapter 1. So most of you are really good in that foundation, but if there's any doubt you have, go and look through those chapters, those first 8 sections from chapter 1. So if you want to stay and ask me questions about anything you have seen on homework, or if you have had a chance to start working on the practice exam and you want to ask me for help, I'll stay here and answer questions. If you want to come and see me tomorrow, I have office hours tomorrow also. You can do that. Again, guys, just as a final note, if you are interested in retaking any of your older exams, you have till Friday to do that. And, not Friday midnight, because obviously I cannot stay up that late. So, in decent time, Friday evening, maybe perhaps the latest. So Billy, the study guide is the practice final exam that I have posted in WebAssign. So if you look at those questions, out of those questions, you say, Bia, that's fine. Out of those questions is what I choose, for my final exam. Now, they may not be the same questions, but they will be the same type of question, same concept. Yeah, Abdul Aziz, so it starts right from section 1.1 from the beginning. So everything that we have done. Oh no, the practice just ends up becoming a longer set of questions, but yeah, no, we don't even have time to do 100 questions in class for the final. So the final is not probably going to be any longer than what your normal other exams have been. Maybe a couple more questions extra, but not too long. Excuse me. Any other questions coming to mind, guys? All right. If not, then I will see you either sometime later this week if you guys plan to retake an exam. If not, I'll see you on Monday morning, guys. So good luck. Study hard and be safe, everyone. I will see you, I guess, Monday morning. Take care, everyone. Good luck. So shoot, I will finish grading the chapter 3 and 4 exam as soon as everybody is done taking it. So probably not till Friday, since I'm giving you guys till Thursday midnight to finish it. I'll probably start grading it Friday. Awesome. Thank you. Hey, Chris.
So we need to have every homework assignment done before Sunday. And if we haven't done homework, like I haven't finished some of the homework on number 1, I have to finish that if I want to do the chapter 1 test, correct?
Yeah, so at least by Friday evening, I would say try and wrap up the exam. So maybe till Friday afternoon or something, you want to finish your homework?
Yeah, I mean, I'm going to do my best after work.
Right.
When are you going to be available Friday nights to do that? I probably won't be off until like 6 and home like 6:30 at the latest. I mean, at the earliest.
Okay, so what time did you want to do your exam then? Did you want to do as soon as you got home?
I don't
or
want
you
to
wanna take a
inconvenience
break?
you.
We can
Yeah,
start at
can I go home
7.
and take a shower or something real quick and then get to it? 7 sounds fine.
7 sounds fine. Yeah, so we can do 7
Yes.
o'clock Friday for your exam.
Okay.
Yeah, sounds good.
And then we have to have 6.7 done, completed at 90%, or the final will not open.
You know, since that's your last section, it's not gonna have any effect on the final because there's no minimum grade requirement for the final exam. Just attendance has to be at 90%,
Okay.
but no grade requirement on homework for the final exam.
Okay, on the 6.7. So you're basically
On
saying we can
6.7.
start 6.7, and if we don't finish it, we're good to go. I can still
Whatever
take the
your
final.
grade will be, yeah, I'll keep that.
Okay, okay. I think I'm good. So we kind of have a preliminary time set, 7 o'clock Friday night.
Yeah,
I'll be there.
okay, sounds good, Chris, thank you.
Thank you very much. Oh, I had one more other question, if I may.
Sure.
Was doing some of the homework last night. I think it was on 4.3.
Okay,
Let me just take this off. It was on 4.3, and it was basically the absolute values
Okay.
of the I don't know what you want to call those points. But basically it was the absolute value, and there was a graph where I needed to plug a point in there for a point. I could not get the graph to work at all. I tried everything.
okay.
I
Did you
looked it
send
up.
me a
It
question
just
about
would not
that?
work. I did send you a question about that.
Okay, I will take a look at the question and send you back an answer because I'd have to look at specifically what the points are. But yeah, I'll send you back an answer.
Well, I think the point was because it wanted the absolute value, and that would come out to like sometimes 13, square root of something.
Yeah,
But it seemed like it just wanted the plots, like it would be basically in quadrant 4, and it would be, since it was, the real number was positive, it would be to the right. And
Yeah.
if the imaginary was negative, it would go down. So I
Yeah.
just needed to plot that point. But again, I couldn't do that. So, on the test, if I can be like, hey, this is the point I'm trying to plot, you can see that and maybe give me the point. I don't know.
Yeah, definitely. I'll do partial points wherever I can, for sure.
Okay. I mean, I can add that to the little ask your instructor, when you're taking the test. So,
Yeah, for sure. I cannot help you a whole lot, but at least I will know that you were having trouble on that, for sure.
okay. Well, thank you very much.
Yeah, not a problem,
I will
Chris. Take care.
get all this done.
All right, good luck.
Bye.
Bye-bye.
Thanks.
Thank you. Hey, Ozzy.
Hi, I had sent you an email about 2 questions I wanted answered, so Hugh can go first after, or if she has another question as well.
Okay, yeah.